know that pressure is given by force over area. So today we will derive the formula that says pressure in the liquids is given by rho Hg, whereby the rho it stands for density, H is the depth of water, and G is the gravity. The gravity, that is acceleration due to gravity. Now let us proceed to find the formula itself. Since we have the formula that says pressure is equal to force over area, okay, let us substitute what is force. We need to ask ourselves, what is this force exactly? So we say F. We know that F is given by mass times gravity. That is gravitational pull. That is gravity. So M times G. Okay. So we take mg and substitute where there is an F. Listen carefully. So we rewrite this formula by placing mg where there is F over A. What is there? It is the area. Okay. Let us move on and see what is this M. M is mass. So again, there is another formula that relates mass, density, and volume. So mass is given by volume times density. Volume times density. Okay. In short, M is equal to volume times density. This is density and this is volume. Okay. Again, you take rho and V, we substitute where there is M. We take everything here where there is M. Okay? So we move on with P. P is equal to, we know it is M times G, but our M right now it is rho V. So you write rho V, and rho times G, then outside there is gravity all over and air, correct? No problem. This is now how we derive the equation. We want to derive the equation. Remember I told you we are only deriving, okay? We bring it into reality. How is this formula? So before you might see the formula here as rho H G, but where is it coming from? That is our main interest. Is that clear now? So our interest is to know where it originates. So from here again, we use V. V is volume. V is volume is given by area, that is cross-sectional area, multiplied by height or depth. So V is equal to A times H. It is a matter of substituting. Substitute and substitute. Relax, we are moving on. You see where there is V, go and substitute A times H, correct? So we take the same formula, but we substitute V. So we say P is equal to rho multiplied by AH, which is the V. So times A times H. But remember there is a G, don't forget it. So you write G. Now, there is A here, don't forget it, over. Never forget it, there is over A. So all of it divided by A. Okay? Now, what is remaining actually is to simplify. We are supposed to simplify. What is common between them? It is A. So, that means A and A will cancel. A and this A cancels. Therefore, the last equation follows as density multiplied by depth multiplied by the gravity pull, all of it will give you the formula. That is now how we derive it, okay? So finally, you rewrite it as rho H G. You can rearrange, you can start with G, you can start with the H, you can start with the rho, any factor is okay. So pressure in liquid actually is given as rho H G. You can also say H rho G. Or you can write H rho G. This is the common way of writing this, the easiest way, okay? So now density of water is constant. For water it is constant, but other liquids like seawater has a different density from fresh water. Okay. Now if you look at diesel has another density. If you look at petrol, a different density. Okay. Fresh water has a density of 1 gram per centimeter cube. But in terms of kilogram per cubic meter, it is 1,000 kilogram per cubic meter. Now from here, this is now the end of derivation. We have derived the formula. Now it comes to the end of actually the lesson. The next lesson will be about the factors affecting pressure in liquids. The next lesson is about factors affecting pressure in liquids. Thank you very much.